Okay, to graph this function, remember, think of f of x as being the same as y. So we need some xy pairs that are on this function's graph. And notice at negative 3 there's a problem. When x is negative 3, y is undefined. That's important to know. And that'll be a vertical asymptote for this function, in fact. But anyway, let's find some other points. If x is 2, then y is 0, because 2 minus 2 is 0, and anything goes into 0 times. If x is, let's see, let's find some other values. If x is 1, then this is equal to 1 minus 2 over 1 plus 3, which is negative 1/4. Negative 0.25 is negative 1/4. And what if x was equal to negative 1? If x was equal to negative 1, then it's negative 1, negative 2 over negative 1 plus 3. Negative 3 divided by 2 is negative 3 halves. Is negative 1.5. What about at negative 2? At negative 2, this function equals negative 2 over negative 2 plus 3. So that's negative 4 over 3 minus 2 is 1 is negative 4. So there's a few points on the graph. There's also perhaps some points on the other side of negative 3. How about negative 4? When x is negative 4, this becomes negative 4 minus 2 over negative 4 plus 3. That's negative 6 divided by negative 1, which is positive 6. So this function equals positive 6 over there. Let's find another point. What about negative 6? So if x is equal to negative 6, this function is equal to negative 6 minus 2 divided by negative 6 plus 3. That's negative 8 divided by negative 3 is 8/3. And 3 goes into 8 twice with a remainder of 2. So this is 2.67 approximately. 2 2/3. Let's see what other values. Let's find maybe one more. What about at 4? Positive 4. Then the function equals 4 minus 2 over 4 plus 3, which is 2/7. And 2/7 is about approximately equal to 0.29. Approximately 0.29. Okay, let's see if we can graph this function knowing all of these points. So let's try it. X goes from negative 6 up to 4, so let's plot that over that region. So 1, 2, 3, 4, 5. There's negative 6, and 1, 2, 3, 4. That's the x extent of this. And y goes, it looks like, goes down to negative 4 and not up very high. So let's go up 4 and down 4. So 1, 2, 3, 4. I should try to make these scales pretty as much the same as I can. So let me do that a little better here. So down 1, 2, 3, there's negative 4. So first of all, let me draw on the line y equals x. That's just the diagonal line right through the middle. So there's the line y equals x, where the y coordinates are all equal to their x coordinates. The point 1, 1, the point 2, 2, the point 4, 4. The point 4, 4 should be right about here. Anyway, let's plot the points on the function in black here. So at negative 3, the function is undefined. That's negative 1, negative 2, negative 3. That means there's actually a vertical asymptote in the graph of the function at that point, we're going to see. The function's not defined there. There's no point on the graph, but we have negative 1, then go down negative 1.5. So there's negative 1, there's negative 1, and negative 1.5. It brings us down to about this. There's a point on the graph right there. Negative 2 and negative 4. So negative 2, we have to go down to negative 4. So we come down to about here. That's a point on the graph. Oh, when x is 0, let's do the point. When x is 0, negative 2/3, which is negative 0.666 or negative 0.67. So that's when x is 0. So at 0 it goes to negative 0.67. The intercept is about there. And let's see, when x is 1, we go to negative 0.25, just a little bit below the x-axis when x is 1. When x is 2, we're at 0, so here's where the x-intercept is. Our curve goes through the x-axis right there. And at 4 we go up to 0.29, so just ever so slightly above. So it looks like this part of the function has a graph that looks like this. So the inverse function has a graph that looks very similar, reflected through the line y equals x. If we reverse the x and y coordinates, we have the graph of the inverse function. So this is the graph of this part of f. We didn't do the part on the other side of negative 3, but let's stop here on this one.